Welcome everybody. So today we are going to discuss how to use the sensitivity analysis, and in the problem is our problem is about net present value. So the problem description is that a friend is willing to invest $14,000 and his estimated cash flow is 5,000 per year for the next 6 years. But there is some uncertainty because the cash back may fluctuate between 2,500 to 7,000. There is another option of depositing in a bank, and the bank interest rate, estimated interest rate is 11%, but it could vary from 9.5% to 12%. So now, based on the net present value calculation, we are going to decide whether he should go for that or not. So let me first we could develop this problem into the Excel. In the Excel, let me first write the cost. We know the cost is 14,000. As this is negative cash flow, I'm writing negative, and then according to the question, it's given that the year 1 cash flow is 5,000, and this is for year 1. Let me drag it down so that we get the year 5, and this is also same for the rest of the 5 year. Let me make it sure. This is the base value, which is the estimated base value, but it could fluctuate between certain range. We will write that after that. So let me write these are our input, and our interest rate is 11%. Let me make this format as a dollar. Here you go. This is our base value. We can insert a row, insert a column before that, and this is our max. This is our mean. Our cost was same for the all 3 years. There was not fluctuation, so that's why we are keeping these values same for. But the cash flow is variable. It varies from 2,500 to 7,000. Which is same for the next 6 years, and the interest rate vary from 9.5% to 12%. So these are our data. Now let me insert another row here so that we can play with that, and I can rename that column as input, and I can copy this value from here to there. Now we will play with that. Okay, let me we have to calculate the NPV, and we know in the Excel by using the Excel formula. Let me press equal sign, and then I can write NPV. I can see that it comes up. I'm clicking here, or you may place the tab, so it shows that you have to write the rate, which is the 11%. So I'm selecting this one, and then comma the value 1 to 3. Now here one thing in Excel, for the NPV, we always the value 1 2 3 are the year 1, year 2, year 3 transaction, and all of these are future transaction. So we have to select from year 1 to year 5. These are the values, and then close the bracket. But remember, there is another cost at the beginning of the year, which is year 0 or beginning of the year 1, and we need to consider that. To consider that, we will add these, just add a plus sign, and then we will click over there. We use the plus sign because there is already negative value inside the cell, so plus should be okay. And now press enter. Now you can see we got the NPV, which is 4000 some. So we got the NPV. Now we want to see, okay, how the NPV changes by the changing of this variable. We can easily do that using either precision tree or top rank. We prefer top rank for this purpose, and we also the question we're also interested for the tornado and spider diagram. Okay, we should first open the precision tree, top rank. Okay, let me open the top rank, and then we see the in the top rank tab gives, and now we will add this as an output. I'm okay with the name, and it gives the formula, and then I will add this as input. I'm not interested with the plus minus variation, but before that let me add input, and then I'm clicking here. Then from the drop down menu I can change the actual, mean and max. When I actual, mean and max, and then click OK. Now I can change the mean and max. Now we know the mean value. Oh, the cost is not changing, so we should not consider it as a variable, so it's not bad. Okay, cancel it, and let's see whether okay, so everything is fine. We should consider this as a variable. So cost was not variable, this is variable, and we click input, and then we can change the from type, the type 2, we'll go for type 2 actual, mean and max, and then click OK. We are using the uniform distribution. If you are willing to use any other distribution, that's also fine if it is on the question, but in general we use the uniform distribution, and 5 steps is the default value, which is okay. Minimum is the 2500, let me click 2500, and maximum is 7000. Okay, now here in the 5000 we can use the link so that we can drag the cell. Just click here, it will D3, you see D3, and then for the 2500 click on here and select the 7000 and click this one. Now it should fine, press enter, and now we can drag it down, and you know what, we can drag it here too, see. Okay, but what happened, it copy the formatting. I don't want in dollar formatting, it should be percent, so by clicking here I can change it to for percentage. So now these are the X variable, and this is the, now I can go for top rank simulation. Before that, let me check the report settings. I need the sensitivity graph, clicking here, and then run what if analysis. Click run. Which is also the range. Okay, you know what, there is another model is open. I need to close the other worksheet because of the version that we are using. It's not the professional, it's the education version. Okay, let me now it should work. Here we got done. So we see that the year 1 input is the most influential variable on the NPV, and from the spider diagram we can also see that cost has the, but we know that cost is fixed, but other than the cost, the year 1 is red color, and you can see the red is the have the greatest slope. So year 1 has the biggest impact on the NPV. The cost also, cost must have an impact on NPV, but as cost is fixed, so in the sensitivity analysis we don't require any explanation for that. In the sensitivity analysis we can see that how the value of year 1, year 2, year 3, and this is the summary, and that's all about for today. Okay, if you have any question on these spider diagram or tornado and NPV calculation and sensitivity analysis, then let me know. Thank you very much.